Welcome to the BUA BATHO podcast. It's a podcast that seeks to bring the career conversation to the fore. We realize that are happening out there. There's so many conversations that need to be brought out to the fore. And to discuss more about careers, there's a lot of people who are going through career issues. People are changing careers. People are having workplace, whatnot, and all of those things. Young kids are graduating from the BGCSE, transitioning into tertiary education. We therefore need something, a platform that will be able to just break down the conversation, earn them a lesson. Every one of these people that I just described, to reinvent themselves, just to see what other people are doing. Botswana, Jakabone, what amazing work they're doing, what informed their decisions, and just to learn a thing or two. Welcome, Tebogo, Mogaleemang.
Thank you, BATHO. Thanks for having me on the show. Really love the work that you are doing with this, and I see this growing to become bigger because of the crowd that you are targeting. Really,
that's what's up, man. This guy na haisa batho botlhe ko sekolo. I think na no tsena ko bokamoso CGSS I get. Maybe we do CGSS na kwate.
Yeah, the community part was still alive.
I think we met Kona lady. Then we went to UB Rote. He was doing the science. So we were studying BSc.
Yes.
For 2 years.
2 years, then got a scholarship to study engineering in UK.
What engineering?
Telecommunications Engineering. So I did year 1 at University of Essex. Yeah, but it was a bit easy. So I wanted like a more of a challenge, and the next challenging thing in the same field was at the University of Southampton. So then I transferred to the University of Southampton to go straight into an MH program, Masters of Engineering program. So in UK, you can either do Bachelor's of Engineering for 3 years, or you can take 4 years and then do a Master's of Engineering. It's a quicker path to become a chartered engineer there. So it kind of combines not just the technical side, but the management side, the legal side, and all the other softer skills that are needed for the success of engineering in our society.
Telecommunications Engineering.
Yes, sir.
Wait, before we work on.
Yeah.
Let's go back to you, and I think I met you've always been academically gifted. It's in no batho ba ne re bana ba ne le bofana ba reng ka prize giving ha rona ha subiletswa back ko stage ha rona ha tsa prize tsa a retima, so rona le tlha go tle re sala ka tsa bo English lebo
your compositions, mate. Do they know?
But I think when I look back, this thing, Edmets Mr. Chelsea about her assignment. First lesson about her assignment, I think about 10 pages or something.
Yeah.
Abari, you are free. Come Monday or bring back my textbook, and then you can go and sign for other options.
Yeah,
I was one of the people Nalbo Parks
who did
and I met him a couple of years later. I think Mr. Charles used to teach me Edmeds about and then what happened? They became that assignment that you gave us. Then he's like, yeah, I can tell. What are you doing now? Are you in the creative field? Yeah, I am. How did you know? I can tell by your pants. So I think I have always been, like you're saying, the guy when I more on the creative end.
Yeah.
And then you have been the guys when I was not and all of those guys who are academically gifted, like on a major level.
Yeah.
did you know then or you wanted to do a science-related education after Naledi?
No, back then it wasn't, there wasn't as much information as now for you to be able to plan your path down by about 10 years or so. And there were not a lot of engineers around, so you couldn't pick someone and role model yourself, like your path forward around them. So it was more like, all right, there was this undeclared expectation and more like a rite of passage that if you are good in maths and science, you're going to study BSc and then go overseas, pick some engineering course, and then that's where you'd go. So I'll be lying if I said I knew what I'll study. But what I know is that around standard 3, I had read a book about astronauts. So the first composition we wrote, what do I want to be when I grow up, which is quite limiting because you tend to think about what exists
What
now.
you're exposed to,
and then but I did write that I wanted to be a scientist. So science, I knew it was going to go into that space, but I didn't exactly know what. But after like the first year of BSc, you kind of then start seeing that even in the engineering space, there are those courses that you'd be told are more kind of suited towards your marks. So it's not about, it doesn't start first being about what you are interested in. It's your marks in school leading you towards that. So if you pick all engineering courses, the most mathematical of them all is telecommunications. Most mathematical. By far one of, even overseas, it's the one that trips most students because it's a highly mathematical. You're doing physics, you're doing that. It's a multidisciplinary engineering discipline.
Yeah, so, okay, now that you've answered that, BSc,
Yeah.
then kind of have never really understood what happens after that 2 years.
All right.
Choose maybe somebody about no, now I want to be a doctor, or I want to be an engineer. And then how do you know of all the engineerings?
This is the one that I want.
This is the one that I want.
All right, cool. So, like I said, it's marks related. So the government would then have a list of courses they've identified, or we have a shortage of capacity in these areas. So they'll release a list of courses they'll be sponsoring students in. I think even Botswana.
This was in 2004.
Yes. Yeah. So they would have that. So then you are there in class, then you are ranked. So if you are, depending on where you are, marks wise, you then pick 3 courses that you want to do. And if you have done well, you get into your first choice in engineering. So most people really didn't get that first choice. So which is why then I had said it's determined by your marks more than just what you want. But then with medicine, it then comes to, all right, because the reason why we had to go through UB is we don't have A-levels. Because we don't have A-levels, by international standards, students globally would do their A-levels before university.
That's right.
So for us, this is to close the gap between BGCSE and then A-levels, so that by the time you get into year 1 at varsity level overseas, you have the fundamentals in place. So this is why in UK they can do a BEng for 3 years, because the fundamentals are done at A level in terms of the maths that is required in engineering and all that.
Course, yeah.
So, and just to contrast with locally here, for students who don't do that BSc, if you take a standard Bachelor of Engineering degree at BUST, it's 5 years, because they compensate for those 2 years. So that's why it's longer. Yeah, so it's still a factor. It's something that needs to be covered, because there is a huge shift from how you should approach education at tertiary than how you should approach it at BGCSE. So at secondary level, it's more route-based learning. It's about your ability to recall. It doesn't force you to internalize and create your own mental model of the subject and then build on top of that. And then this is where most students struggle when they reach tertiary education. They think the ways of studying they used to employ at secondary school level.
I remember I had the culture show.
Yeah. We think it would work at university level, but university studies, truly speaking, require you to be more self-driven as a learner.
Of course.
It requires
There's
you
minimal
to
supervision there.
deeply internalize the concepts for you to benefit from them. So that's why we did those 2 years. It was to really close those gaps. And just to share with you, for me, it did greatly benefit. From what I saw, it did greatly benefit us when we reached UK because any course that was mathematical, that's where Botswana student would excel. But those courses where they rely on more like the creativity with computers, because we would see computers for the first time overseas, that's where like local students, they would do much better than us. And it's something that even like our professors would notice. And then they would call us and say, hey, you guys are doing extremely well in courses that we consider to be very difficult. But when courses that should be very easy, you guys are kind of struggling. So I think the
GC
it really helped. And I think when I look back, I think that's why for me the course that I chose to do became really enjoyable because once I broke it down into the maths. From just how you're capturing signals, how this mic works, it's converting pressure waves into electric signals. So I can literally visualize what is happening and also think in terms of the maths. So if you can understand the maths, you don't need to memorize because you can explain it in first principles. The same way I'll tell you, a few years back, I was just bored. So then I started, what's finance really all about? Then when I started learning the fundamentals, these are some of the really simple formulas we learned, and this is what they mean. And then I was like, finance makes so much sense. So math is a language for abstracting the real world. And then it also offers you the tools where if a problem, if you can instantiate or reduce a problem into these mathematical structures. These are the behaviors. This is the tool set that you can use for these sort of structures. I think if I'm to just go back, this is why I got really interested in mathematical optimization, because in telecommunications, what we really are doing is we want to send signals over the interface, be it wire, be it the air interface, be it fiber. We want to send as much information over that channel without distortion, but also getting clarity, higher throughput. It's an optimization problem.
Of course.
The same maths that I used to use for that applies when you do portfolio optimization, applies when you do route planning. If you were to plan routes for collecting trash, I would reduce what has to be done to the same level of maths. So then you see that maths then doesn't become a subject. It becomes a problem-solving tool, which is why really...
And you can apply it almost anywhere.
Yeah. So and you can then learn any field because the maths would be the same across the fields normally. You can then teach yourself any field and not struggle because you can reduce it to the fundamentals. It's a toolbox, not a subject.
Ke le mkholo re bua thata ka matso gore wa no betsa wa go mpolaisa director ra me because an go sound it ntse ikokota mo ha.
I'll do my best.
Tell us about telecommunications engineering.
Yes.
What is this thing? How, Kraru, what is it?
All right. So I'll start from first principles. So when we are talking and there is no technology around, we speaking voice. So I'm communicating via voice. If we keep increasing the distance between us, at a certain point we need to shout. If we keep increasing the distance, at a certain point it can't work. So at that point, what do? Either I write you something down and find a way of conveying it. But it's also limited as well. So if we want to communicate, we need to find means of carrying my voice over some form of medium down to you. So you think the telegrams, you think the old technologies, the landlines. Let's start with landlines. So with landlines, there really had to be a physical line from my house to a pole, and then it had to go down to the company, the telecommunications company, and then at the telecommunications company, they do a bit of switching, then it goes from there, and then it ends at your line. Now that is limited to the amount of information you can put over the copper wire.
Of course.
Yeah. So now what did we do? We're like, the copper is not effective because you then need to put lines really in between people. You can think there has to be a direct line to everyone's house in a way. So then telecommunications, actually, let me say this. The old way with landlines, you'd call an operator and say, operator, I need to speak with someone, then you'd give them that line. Then they would physically switch you.
Yes.
So that they plug those two lines. And they used to make mistakes and you'd speak with the wrong person.
Yes.
But with telecommunications, then the challenge is, how do we simplify communications? And the initial target was really to convey voice messages. But once we solved the voice with technology in the middle to automate the switching, it then became a case of, maybe we can also exploit other mediums of communication, the air interface. The air interface then brought us the first generation of cellular phones. Walkie-talkies. The Roger. Yes. So in telecommunications, the challenge is you have an air interface. This air interface, you would have frequencies. The main resource is a frequency. Most of us, when we switch radio on in here, Yarona FM 106.6, RB2 103.0. What are those? Those are frequencies. It means we can set radios to communicate at a particular frequency without interference from other people. So with RB1, they are transmitting at 89.9. With RB2, they're transmitting at 103.0, taking advantage of the air interface because we can then communicate at that frequency. The other person on the other side tunes to that frequency, and then they're able to get the message over that frequency. You can now see, or then someone can maybe send something again to jam your signal. Yeah. So then we need more intelligent ways of making sure that we separate the communication channels and all that. So we then go higher. These work at about 1800 megahertz, 2100 megahertz. So we take advantage of frequency bands to send signals. Main resource, frequency. Why does BOCRA exist? BOCRA manages the frequency spectrum. So it's like the main resource. So in telecommunications, we keep finding clever ways to send more signals so that we can have multiple people communicating over the same line. And We then do it in clever ways. We look for clever ways to also ensure that the signals are secure. Nobody can listen maybe to B's line. With walkie-talkies, if we're in a forest and I'm communicating with you over Roger. If someone else tunes to that frequency, they can listen to us.
Of course.
Yeah. So compare that with Bluetooth. Even though Bluetooth, we use the same kind of frequency, but we are doing something clever, we hope. We make it unpredictable, but if we have paired our devices, they will know which channels to exploit. So telecommunications really is about sending messages, making sure we send as much as possible over the frequency that we have chosen, and ensuring that the messages are secure. So started with voice, then once we figured with voice, we wanted to share more images, movies, video calls, and text, SMS and all that. How do we send text and all that? So it's an engineering degree that is really dedicated to sending messages in a secure way and ensuring that even when conditions are bad, like when there's rain, you still get sufficient coverage and all that. So I'll reduce it to an engineering for maximizing our ability to communicate and send messages, and messages can be anything really now.
I've never heard anybody break down that course the way you just did. It was so amazing. Interesting. So, you were taught all of these different mediums and outlets and what have you.
Yeah.
So all of this was covered through the duration of your studies.
So we'll do the maths basics, copper wire, basics, A interface. You guys, we did the physics in senior school, but they didn't make it relatable. Remember like that formula, like the speed of light equals to the frequency times the wavelength. You guys used to memorize and say something like C equals to F lambda. Stuff like that.
Number E equals to MC squared.
But you'd remember we were about gamma ray, X-ray. Yeah, that's the spectrum. Yeah. And the interesting bit is you can't send, you need to understand the properties that come with each mode that you want to communicate with. You need to understand how signals relate on copper. Copper, electrical signals. Fiber, it's we send in light waves. So you need then to understand first the mechanics, the physics. And then the other thing on top is that you then need to think about the electronics. How do we build the electronics so that we are then able to send all that? This is why I said telecommunications is considered one of like the really challenging courses, because there is the math side, heavy physics, and then there is also the electronic side where now you need to think about building the electronics. Once you've built the electronics, you then need to learn how to program and build the applications that will run this. So then you learn programming. So it's more like computer science plus electronics plus electrical engineering in one course.
Okay. So what are the different opportunities of work that one can find themselves in?
So as a telecommunications engineer, you can either branch into pure electronics and build, like right now you are hearing everyone is talking about IoT.
What's IoT?
Internet of Things. So what is that? So these are just sensors that have connectivity to the internet. Sensors that are able to gather some signal. It can be pressure sensor. It can be a camera. The biggest IoT device in the world is this. I don't know why the brightness is on. Yeah, the biggest IoT device is this. It has a microphone, that's a sensor. It has a camera, that's a sensor. As I turn it, there are things we call gyroscopes that can tell how you are holding it so that it just certain things. Nowadays, we're building electronics, things like fridges, connecting sensors. I want them to send to the internet and all that. So you can either go into designing the devices at an electronics level. Then from then on, you can also go into building the software that goes into this. You can then become an embedded device engineer. So the other one is pure electronics. With electronics, you need hardware on top. The driver alone. Mwana mai kwa me o bereke mo computering sound just the driver ho. Yeah, those drivers are to ensure that the hardware functions well. Yeah, for you to be able to use that. So that guys whose career is just to build those drivers. Then you can either, because you have done the maths, you can either go into also research, because it's quite, there is a need for continuous research. That's why we had 2G, 3G, 4G, 5G now. Others are doing research on 6G, because the challenge is to continuously look for more efficient ways of communicating.
Let's hold it there. What are those things?
The
3G, 4G, 5G.
All right, it's just the architectures, the radio architectures. So 2G was initially just about voice, sending, being able to call efficiently. 3G, if you remember well, we now wanted to also go into the internet efficiently. So we moved from just wanting to send voice
and text
to now wanting to send what we call multimedia. Yes.
MMS, yeah.
So the old architectures were not fit for multimedia communication. So it necessitated research, because now you want to send images, you want to send videos.
That's right.
So then there was a need for a new communication standard. It became 3G. So now when we reached 3G, now we're like, but it's not just about broadband. I now want to have internet when I'm moving, mobility. So then the challenge was, how do we provide mobile broadband? Because as soon as we introduce technology, the way people are using it exposes a limitation.
Of course.
People want to do something, and then the current technology does not allow it. So then that's when we went to 4G. And with 4G, that was the challenge, mobile connectivity. Like, how do I get internet at a broadband speed level, even when I'm mobile? Yes. So now we then solve the mobility part. And now with 5G, we were at that point where we now have more than just computers connecting to the internet. We have industrial equipment. We have these IoT devices. How do we then connect these and still guarantee acceptable levels of performance? Now it became a question of capacity. So then that's when now because some of these are mission critical applications, with 5G now, one of the use cases is a doctor can operate on a patient using a robot from a distance. So then you see that it's very important that for that particular use case, latency, when the doctor moves, the video that comes needs to be in almost real time. Yeah. And then when they move their fingers here, it has to be on the other side. The robotic arm needs high precision. So then the latency between them moving a finger and that being actioned on the other side needs to be short. So now 5G is addressing those kind of challenges, latency, real-time communication and all that. And now with 5G, we're going to find other gaps. So it will never stop, because as soon as you give human beings something, they would find a use case that would expose the limitations. But 2G, 5G, 4G, 3G, these are just radio architectures, like standards. You can think of them as standards.
But let's say the other opportunities. doing your course.
Yeah.
No,
No. Like there are endless, mate. You can become someone who designs computers, can be a computer engineer.
so it's endless, like you're saying.
Effectively, if you, and this is the sad thing with education sometimes that I pick. For me, it's not about the final thing, like the name of the degree. I look at the process of what I went through, what the skills that I had to pick to do that. And these skills are applicable in any engineering field. Really. Like, for example, in industrial engineering right now, they do a lot of what we call control systems. We did that. Deeply did that. Now, if you have done Masters of Engineering, for example, we did management. We also did contract law. So then you can become like a project manager, like an engineering project manager at scale. Because in UK, if you have a Masters of Engineering, it's a fast-tracked way of becoming a chartered engineer. We may not have that here, but I'm just showing you how within the space of engineering, there are multiple areas that you can branch into, not based on the name of the course you did, but the skills that you picked. There are other students who enjoyed the programming part. Then they became developers. Actually, in the early days of Facebook, one of the guys we went to school with, he did electronics, he did everything that I mentioned, but then he went and worked for Facebook, doing something completely different, but they had built the skills. So for me, I tend to think about this more from like the skills capacity. So when you are in school, you are given something, it's to force you to build certain skills, and those skills can be applicable anywhere. Yeah, because I didn't want to become that, as I said, I knew I wanted to return home. That one, it wasn't even like debatable. I wanted to come back home. When I returned, I became a teaching and research assistant at FET in 2008. Up until 2009, I worked on really interesting problems. You remember the time Bakatla? Yes, that tower there. Yeah, I kind of did some research there to just understand. All right, yes, it's a valid concern. If people don't know better, it's a valid concern. But how do we also give people confidence that these systems that we are building are safe? So I did some research on radiation there while at the Faculty of Engineering and Technology. But then I've always craved problem solving. For me, engineering is about problem solving. If you're not solving any problem, then you are not engineering. So I then joined Mascom, my one and only corporate employer in this country. Yeah, but after 2.5 years of working with 2G and 3G technology.
What were you doing there?
I was a core network engineer. So yeah. So when you guys send things like SMSs, you type someone's number. Yes. So when you type someone's number, that message needs to reach that person.
Of course.
It may seem seamless, but behind the scenes, there is some routing that has to be done. Routing, you can think of route 2, route 3. You are taking a route.
Game City.
Yeah, Game City. Even when we are sending messages, we need to route signals. So when you send message, when you call and when you send SMSs, we call that traffic. Network traffic. My role was to analyze network traffic, look for congestions, and then find efficient ways of routing those messages in an automated way, but also in a way where...
we want on traffic ila BBS. Kraru no liba mo go eng wena.
On the computer. So
okay, this is interesting.
When you send us, just like traffic, if you are going to Game City,
Hey.
you have to go along the road. In telecommunications, there are roads, even on the wire, there are channels
Hey.
that you can take. So we'll observe those channels. Wire has limited channels, that's why we abandoned wire.
So to me, the end user, what would then be happening?
No, to you it's seamless. To you are typing, then the other person is receiving. But even if we are in close proximity like this, when you send, it doesn't go to your phone directly. It goes to a tower. Tower takes it to the main switching center at your telecommunications company.
Okay.
That main switching center was my job to ensure that it's in good health, run, look at the alarms, what is not going right, whether these channels are congested. Just like your road, if you are moving from here at peak time, on the road there would be traffic congestion. Even in that channel, there can be congestions. You have seen it, usually it
happens at midnight.
Yes, why? Because there are multiple people calling, they're creating traffic, and the network capacity cannot carry all those messages.
Yes, sir.
So rara emelana boss. Why hit a hadira? So there are those kind of delays. So that was my work, to ensure that we picked on those errors. Then we allocated enough resources to ensure that those messages reached you guys with no delays. And then we would also look at, all right, now those are network resources. How do they translate into? So that we can then advise the other department that you are dedicating more traffic towards things perhaps that are not revenue generating, for example, so that we can then support business decisions. So that was my work.
Very interesting, I must say. So, and then in terms of demanding bio, were you on standby outside the holiday?
You'd go on standby because if the network goes down, people want to communicate at any time. Yes, so you'd be on standby, but I would say it's not really demanding because you have tools that show you everything, and you are not the sad thing about a job like that and really calling it engineering is, in all fairness, you are not doing any engineering. You're more like a relay. You're looking at the problem, it arises, then you pick the message. Sometimes you are not allowed to change stuff there. Then you have to call the guy who owns the infrastructure, either Huawei or Ericsson, and say, hey, I'm finding this alarm because there is a service level agreement. Those guys design the networks, and then they're responsible for anything that happens. And then from then on, someone on the other side tells you, oh, yeah, you can do this. Even if you know how to do it, then you do that. And I think for me, that's why I didn't last in that world. If I figure out a better way of doing something, as an engineer, I have to try it out. And sometimes because of the other commercial obligations and contractual obligations, you are not allowed to do that. So you then go from being an engineer to now more like a technician. In all fairness, with all due respect to technicians, you then become that. You observe, you can intervene, you then send it, and then someone tells you, okay, gives a go ahead, and then you change stuff on that side. So for me, it didn't seem like I went to school to do that.
Where then did you go from there?
From there, I I didn't know what I wanted to do, but I knew that's not what I wanted to do. So I didn't really know where I wanted to go. So I kind of decided I need space. So I left my comfortable and well-paying job and then just decided to just go stay at home, think things through. What do I want to do going forward? It was insane. Still say it's crazy because you need money. Yes, you need the other obligations. But fortunately, I hadn't made any commitments to other people. I didn't have extra responsibilities and all that. So I could be that selfish to think about myself and where I wanted to go. So I then quit. After a year, I got a scholarship to go study mathematical optimization at a PhD level. But I also thought, 5 years, it's not what I want to do. So you see now, because of the mathematical background of my course, I could then branch into other disciplines going forward. Be it in pure math or applied maths, be it any engineering, computer science, and all that. So there was a question that intrigued me when I was still employed at Mascom. So I used to just wonder, why is it that we consistently hear the system is down? So when I was overseas, we're using the same technologies, same things, and things were smoother. And now I'm back home and this is a problem everywhere.
Everywhere, yeah.
So that engineering mind then asked, why? Why is it that using the same technologies?
Which year was this?
I think this was in 2013. Yeah, but it came even when I was still employed in Mascom. Because for you to quit your job is not like a decision you take there and there. It has to be. It takes time because you are processing and it's not a simple decision to make. But then post that, I then started seeing that here in Botswana, one of the challenges we have is that we're not process centric. We never create standards for doing things. We're going to do A, B, C, D, monitor how well we are doing, and then learn from what we are not doing right. So I then started just consulting to earn money. Then as I was consulting, I realized, wait a minute, nobody's doing this in our space. I could turn this into a business. So that's when I opened my first business. But then I didn't have any business training. I was more motivated by the problem than anything. So that's when I didn't make some good decisions there. But, it was a learning curve in terms of, this thing can be scaled there and there, there and there. But then as soon as I started working with companies, you then realize that companies don't get what they want, because if you are sitting together and there's a problem, the first instinct is for everyone to say it's not their fault. Yeah. So then my challenge was, how do I show them what is happening without offending anyone? So that's when I got into the space of using data to show people what is really happening without anyone accusing me of maybe going for them or seeming like I was favoring someone else. And one thing led to the other. And that idea of using data to drive decision making, to show the true levels of performance, or to create a single baseline of truth on what is really happening, has really influenced me into even how the current company that I run, what it's trying to do and all that. So you see, it's moving from just a simple problem, cascaded, and then it leads you to other areas. So I would say I've been quite fortunate in that I've really been able to just continuously apply myself. If there is an area that I don't have an answer to, I don't mind not knowing, but then I know I have to start somewhere and then do some basic research, understand the problem better, and then go back to my engineering training and look for the best tool for solving the job. So it kind of led me from not relying on tech as a solution, but understanding more of what is the actual problem that we want to solve here. And then using technology, again, like a toolbox. So it's not the thing we should be selling. It's a toolbox we lean on to solve problems that we face.
So what are you currently doing now?
All right. So based on that background, I now run a company called Spectrum Analytics. We realized early on that with advances in technology, especially digital technology, all everyone is creating is lots of data. Now, how do you then leverage this data to create business value? So that's our value proposition.
What is data?
Data, not what you use to connect. But okay, let's get data. No.
The units.
Not data as the units, but data as in recordings of information.
Yes.
So when you store, nowadays we have smartphones. You take a picture. So that picture, how it's stored, it's stored as data, ones and zeros. It's not stored as colors, as all that. It's just ones and zeros. When you record a voice note, even when you talk, it's data. So it's more like a recording, more of a record. Think of it as a record. The same way when we are writing letters, a record would be that piece of paper. Now with technology, the record is that data that we share. So companies generate lots of that. With this data, you can uncover patterns, how people are using your stuff. And based on those patterns, you can then make informed decisions. Something as simple as, for example, during winter, we know that there would be a spike in flu. So if we're looking at patterns over the years, we then say, so when there's flu, what's the one thing people want? Our flu medicine. So if you are running a hospital or if you are running...
That's the data you'd use.
Yeah, that's the data you'd use.
To know which medicines to procure.
Yeah, well in advance so that you don't run out of medicine at the peak of like winter. So it's surprising when sometimes my head.
So would you say that Mosadi Rekisang maybe the variety of goods?
Yeah.
Was it data that informed her that if I'm selling cigarettes, I need to also get like a
Yes. So what did she observe? So think of data also as observations. What did she observe? So I'll come buy a cigarette, then I don't have a lighter. So she's thinking, okay, convenience to my customers. From an observation, if maybe in a day she was selling 100 cigarettes and only one person asked for a lighter, it may not matter to bring a lighter. But if 45 or so ask for that, she's hearing it consistently. So that's like multiple observations that make her do that. The other thing is airtime patterns. You buy airtime. If you buy 100 Bula, it takes 2 days. So maybe instead of waiting for it to finish before you buy, you can buy so that you don't close your shop or send someone so that they don't close your shop. Everyone uses data to make decisions. When you're taking your son to school, you know traffic patterns, observations you've made. You know which routes would be congested. So you would have your shortcuts. Everyone uses data to make decisions. It's just that because you're not recording it elsewhere, you call it memory. But it's data and it's quite intuitive. Our forefathers used to observe weather patterns, stars. That's data. And then they'll know when to plow. Yeah. So if you didn't read the data well and you plowed wrong time, I meant low yield.
So spectrum analytics, e batla go irang yone.
So for us as a company, any type of data that you have, we can mine it for insights to allow you to do things better, allow you to make informed decisions, allow you to identify new opportunities for your business. Yes, so that you can thrive from all this data that you are holding.
What is data mining?
Data mining just means uncovering patterns in huge volumes of data. So it's like a mine. What's a mine in terms of diamonds? Diamonds could be anywhere. But you then need to get the raw material. What's the raw material in terms of data? It's all the data that you have. You don't know the pattern. But to find that valuable thing, just like with mining, you get the ore, you process it, and then from processing it, you have the diamond, but it's not usable as a diamond up until maybe you turn it into a ring and then give it to someone. Same kind of logic applies. There is data. On its own, it's meaningless. For it to reveal useful patterns, you process it.
Give me an example.
All right. Let's go back to the example lab medicine. These records of what is being dispensed at the dispensary, there are records that would show you every day what is being dispensed. I get it. Yes, I get it. So you can then go in time and look over the last 10 years, what did we prescribe on these months? What are patterns for July? What do we prescribe more around July? And then in you asking that question, you're actually mining. So now you take all this data across all the clinics in the country. So now it becomes a lot. And because then it's a lot, the challenge is harder. So mining just means the raw material is all those recordings. You process that, apply some techniques for analyzing the data, then you convert it into insights, the valuable thing. But it's not valuable up until it serves someone. So what's the product there? The product would be a better decision. Just like the ore, process it, turn it into a diamond ring and something like that. So with digital technologies, all we generate is lots of data. And it's now companies that globally that are able to gather lots of data, are able to identify new business opportunities. Google, Facebook, your Airbnb, your Ubers, all that. It's because they've replaced traditional companies, but because now they are creating platforms where they gather lots of data, they're then able to understand their user patterns. And then from the user patterns, they're able to provide us with products because they're able to see what we want, understand the market better, and then be able to create products that can serve like that clientele better that way. So data mining would just be the derivation of insights from huge volumes of data.
That's wonderful. That's quite insightful. So are there any projects that you guys have been working on?
Yes, so we've worked on projects I love using technology to show what it can do for people. We have a project called BUA, where we digitizing the delivery of social programs. So we realized that there are a lot of vulnerable people in Botswana, but they're not getting the social services that they need. So we've created a platform where we can register vulnerable people and then register the service providers and efficiently connect the two so that more people could get the assistance that they need. So that's one project. It's still ongoing. There are other projects that are done by Spectrum Analytics, again, would go to companies, pick on specific use cases. We realize that the challenges that organizations face in using the data that they have are related to the infrastructure that they have. So you have to store this data somewhere. And if where you are storing data does not allow you to move it quickly to where it's needed, it would affect your business. So most organizations rely on legacy infrastructure. So they would store data. There would be a mismatch between the infrastructure and then the applications they want to run. So issues that were system down, system is slow, are normally infrastructure challenges. So we help organizations understand the IT needs and then for them to procure the best infrastructure based on what they want to run themselves. So once we solve that, then they can then be able to move data where it's needed,
Migrate,
and
yes.
migrate it and all that. But then the other part of that is with data, it's a double-edged sword now with the Data Protection Act coming. If you are holding people's data, you also have an extra responsibility to ensure that it doesn't fall in the wrong hands, to ensure that it doesn't leak out, to ensure that people's privacy is not compromised. That's what the Data Protection Act would be coming in to enforce. So we also help organizations identify gaps in complying with the Data Protection Act itself. So we can come in, plug an artificial intelligence tool that can then analyze data wherever it's stored and show you, oh, in this file you have an ID number. In this file you have a passport number. In this file you have a credit card number. And then so that you can then control who has access to that data. You can then control who it should be shared with. And then you can get notifications if it's being abused or things like that. But then the other thing that we do, because we focus on infrastructure and data management, would be related to using AI for ransomware protection, for example. The guys on the other side who want to steal your data because it's that valuable, they want to get it. And they're leveraging intelligent ways of getting it, machine learning, artificial intelligence. So you can no longer defend your infrastructure using traditional means. So we then provide AI infrastructure that is able to detect intrusions and even protect the data automatically, lock everyone out. If it starts seeing unfamiliar usage patterns that are suspicious, or signatures in terms of accessing infrastructure that kind of relate with intrusions and all that. So for us, we address infrastructure and data management challenges for organizations.
How has been the uptake so far?
Since COVID, I think pre-COVID tech companies here struggled a lot. But since COVID, there's been great improvement. And then with the pressures for Data Protection Act, we're starting to see improvement in the quality of engagement. In other countries, they're quite advanced. These are basic problems. They're quite advanced. But because of where we are in terms of maturity as a company, it's only now that we are taking first steps towards getting to everyone's level. So the conversations take time, but they're worth it, and there's some positive response generally.
I think one of the things that really stood out as we had this conversation was that you were an employee immediately after graduating.
Yes.
Then you took some time off, a meeting.
Yes.
And then you came out of that now, or no, now I want to be an employer.
Yes.
Can you just kindly tell us, Hori, what do you think is necessary? Because I feel that the country where it is, Botswana, I think we're sitting at around 128,000 public service year.
Yes.
There's been calls from the IMF that we are oversubscribed in that regard, and that we need to take it down a bit. We're at the crossroads. Country be a certain amount of the the private sector needs to grow.
Yes.
And the private sector, yes.
Yes.
It's because of people like you and me who then would take up space.
Yes.
That would actually now grow companies that would later on become big companies that
Yes.
actually employ people.
Yeah.
But then it was all based on that decision. Can you just take us through and then maybe also tell us while you're at it, what do you think needs to be done? They have, I don't know if it's an obligation is the right word to use, but we all can't be employees.
Yeah. Although I have a different take to that, I think we diminish the value of being an employee. Mm-hmm. I think even if you were to create your own company, you would need employees.
No, definitely.
So if we put down employment in that respect, we'll all be running one-man companies.
I think if you look at our current unemployment rate,
yeah,
for us now to be able to take up the 25% and bring it down, then needs to be more employers than the economy is currently churning.
No, but I think to answer your question, but from a different direction is, where do opportunities come from? Mm-hmm. They come from problems. If we are not going to be honest about our challenges, where the problems are, we also are dishonest about where opportunities lie. So also, we should then incentivize people to identify problems and then dedicate time, because it's time consuming. It's madness if you ask me. You need to have a certain level of carelessness to kind of go into do what I did. So I wouldn't blame people out of economic necessity to stay in employment.
Of course.
You see. But if we can incentivize problem solving, reveal problems and not hide them, and then challenge people to reach out, and if you have the best idea for solving a problem, then we can invest in you. I think that's the only way to get around what you are saying, because within organizations, employees would identify problems. I went through that when I was in employment. But then when you find a problem and you try to work on it, sometimes the structure does not allow you to apply yourself. So that's why nowadays there's the talks around more like intrapreneurs. Like,
I've heard of a concept like that.
Yes, so you are internal, you have identified a problem, and then you can make it into a business. Remember the story about this other guy who created that Called Me Back thing?
That landmark court case.
Yes. So he saw a problem, created a solution, and then you see it can become that. So it's really about, for me, it's about giving people the confidence to pick problems and solve them, knowing that if you have built the best solution, you can then have economic rewards, whether you are employed or not. So I think it's because even for those who are risking it, the rewards don't match the level of effort some of them put in.
I actually once watched an interview I had Denis Ortan, the former CEO of FNB Africa, based in SA. He once he built a culture where solutions actually this thing a hierarchy. A solution, it needs to go through your line manager, then your departmental head, and all of those things. About King Roman, he named a number of solutions. So FNB. Where they came from the people on the floor that deal directly with the client. And that's where the problem exists, and that's where the solutions is going to come from.
So what do we do as a country most of the time when we have problems? We call consultants. I swear, the lady who's assisting people at the Omang office knows more about the inefficiencies that
Of the
any
system,
consultant
of
you
course.
can bring. So if that lady is not incentivized to bring those problems to the surface and think about how to solve them, then that would stay as a problem up until maybe management comes with something. So you see, like for us, we talk about a knowledge economy. And what we do on the ground shows me that we really don't have like a practical understanding of what a knowledge economy is. Knowledge economy is very simple. I know something, I have some skill, I can apply that skill, create a value-adding product or service, and then get rewarded from that. USB, you are creative. Knowledge economy, you're applying your ability to do that and then monetizing of that. When the Chinese came up with Kung Fu movies, they were applying that. Hollywood, the ability to act. It's not about the science. From Botswana, when we think the knowledge economy, we make it technical. So if that person at the forefront of Umang office is not applying themselves, we can't have a knowledge economy. Anyone in their own role, there are certain things that they're aware of that the rest of the people in the organizations are not aware of. Let's create a culture where people can come in and say there's a problem here, and it's not looked as bad-mouthing anyone. But we have this conservative culture in management especially, where if you say we have a challenge here, management is saying, don't talk publicly about that. And it has become like our limitation, because up until we show those challenges and admit them, those maybe with the capacity to solve them cannot apply themselves to build enterprises out of them. There isn't a single company, valuable company in the world that is not addressing some form of a challenge. But for us here, we don't value problems enough to see them as sources of opportunities. And all innovations, to be honest, are driven by that curiosity to identify problems, dedicate time to solving them, and then knowing that even if you don't know how to solve it now, but you can then iterate, test this, you learn. Move to the next level, test other things, you learn. And then over time, you've managed to solve a complex problem by breaking it into stages where you are testing simpler ideas and then growing from there. I think it takes that more than people getting out of employment, because you can be an entrepreneur, you can be employed and still have the same mindset, and you add value for your employer.
Thank you very much, Tebogo, for having this discussion with us. I think definitely we hadn't really exhausted some of the things that we wanted to talk to you about. I think we should consider actually calling you back again to the platform and extending our conversation. But it's great to hear about the amazing work that you're doing. It's also great to hear about the amazing work that your cause and one last question.
It's all electrical signals, it's all electrical signals. You are right, and I think I'll take you on your word. Like sometimes I think people don't really realize how amazing this thing is. This course really is, because you do something. Is it sending the letters? But it's just electrical signals. So it's I'll take you up on your word. But because I also love explaining this in ways where you don't think you need to be doing the hard bit. But it's an amazing thing. But thanks for having me, B. I think unscripted as our conversation was, it's been pleasure sharing
Those
a bit about what I know. And I think because we didn't have a structure of what to discuss, my opinion, and I felt energized. Like sometimes you took me back to stuff that I really used to enjoy doing. Thank you for that. All right.
And that's a wrap.